Hello friends, welcome to Power Electronics. Today we will discuss the class C commutation, which is also known as complementary commutation. We have already discussed the class B commutation. In this class C commutation, the thyristor carrying the load current is commutated by transferring its load current to another incoming thyristor. So as you can see in the figure that it has two thyristor. One is T1 and another one is T2 with one capacitor and two resistor. Vs is the supply voltage. So how it works? We have also taken the initial condition in class B commutation where the capacitor was initially charged with the voltage Vs. But here it's not the same case. Here the capacitor is not initially charged. So how the current flows? When the gate Ig1 is triggered, the thyristor T1 starts conducting. So that means current start flowing from this path to resistor and to thyristor and to return path. Also the current flows from this path to R2 and through this charging and through the thyristor. So there are some of two currents available here. You can see this by the graph. Here Vs by R, as you can see, 1 by R1 plus 1 by R2. The voltage across the thyristor is 0. Why? Because the thyristor T1 is conducting. This one is conducting, it behaves like a short. So that means there is 0 voltage across it. Voltage across the thyristor 2. Some of the it starts somewhat rising at this particular point. Also same with the capacitor. Capacitor starts charging through R2. This capacitor starts charging here by R2. There is some kind of drop, so it starts charging. So as you can see here, IT2, that is current across the thyristor 2, is almost 0 because this thyristor is not conducting. That is why IT2 is 0. Also as the charging current is charging now the capacitor. The capacitor was initially not charged, so it is charging, so it rises from here. So Vs by R2, so this is Vs by R2. It exponentially decays somewhat here and reaches a point here. When the capacitor get completely charged as the source voltage, then the current stops flowing. The only path left here is the current flows through this R1. So you can see that the current is Vs by R1. As these voltages, supply voltages, Vs equal to voltage across capacitor equal to voltage across thyristor is equal, so that means current is 0. So it only flows through a path Vs by R1 at that point. So what is the across Vt1? Vt1 is still 0 because thyristor T1 is conducting. Also across the thyristor, second thyristor T2, the voltage is the supply voltage. Why? This voltage of capacitor is same as the thyristor voltage, as you can see, plus here minus here. That means same voltage across the thyristor. IT2, no current flows through the thyristor 2 because it is not conducting. Also the charging current is 0. I have already explained why charging current is 0, because the capacitor has not charged up to the source voltage. These both are at the same potential, so no current will flow until unless that how to off the T1. So to turn off the T1, the thyristor T2 must be on, or T2 is triggered at this gate pulse Ig2. So What will happen after that? Yes. So you can see that voltage this voltage goes to 0. Why? The thyristor T1 gets off. T1 is now off. What changes the thyristor VT1 now have? It have a negative here and positive here. So that means by this the thyristor gets turned off, because now the path for current flowing is from this path to this path and from this path to this path. I will explain again. Now current will pass from this path to this path and also from R2 to this path. Sum of two currents. So as you can see, the across the VT1 is the supply voltage minus plus. So it look like this. Voltage across the thyristor 2. What is the voltage? Previously it was charged to the source voltage, now it gets to 0. Why? Because it acts like a short. So voltage is 0 here. If you look at the capacitor condition, capacitor discharges to 0. Why? The charging current now discharge through in opposite polarity with the thyristor T2. So it gets discharged here. So IT2. So current is also decreasing. Here it is, current is also decreasing at that particular point of time. Also you can see that there was voltage minus 2 Vs by R1, but now it goes to the negative value. Why? Because the charging current changed its direction. Previously the charging current was in opposite direction. As you can see, it is in the opposite direction, and try to recover now. Try to recover and reaching a point 0 here. As we have seen that what happens when the T2 gets on up to this particular condition. After that, the thyristor across the thyristor VT1, the voltage is almost constant Vs. Also the thyristor V2, which is short, is almost voltage is 0. Also this charging capacitor decreases and reaches a point minus Vs. If you look at I2, Y2 current, what flows through across it? Now this voltage is equal to supply voltage. So no current will flow here. Only current path that is flowing is from this path to R2 to T2. So that's why now it is left with only Vs by R2. Capacitor is charged with a negative supply voltage. If I discuss here, the current charging current is 0. I have already explained that whenever the potential gets same, when the capacitor when any capacitor charged up to the supply voltage, then there is no flow of current. Why? Reason is that both of them have the same potential. So charging current is 0 up to this point. Now again, when the thyristor T1 is on, this thyristor again starts conducting. Here this thyristor again starts conducting. So what happened here? How the current flows through? How current flows through this thyristor? It is the sum of the two currents. That is, here one path is this, another path is this. But now what has changed here? The thing which is changed here is twice. Why twice? Because the capacitor is having the polarity plus minus. So from this minus Vs, then it is having minus Vs, that is minus 2 Vs. So this 2 minus Vs by R2. So Vs we have taken common. It is, if you multiply inside, we get Vs by R1 plus twice Vs of R2, that I have explained. Now after that, how it rises and passes from here. What is the condition? What is the condition across this thyristor 1? It also gets short and it remains short. Again, when it starts flowing through this becomes short. Also, the voltage across the thyristor 2, here it has negative and positive. That means the thyristor is not conducting. The voltage across the thyristor is almost the minus supply voltage. Here is the negative sign. Also current through the IT2. So no current flows through IT2, so it is absolute 0. Also, what about the charging current? Charging current rises from 2S to Vs by R2 and starts discharging through thyristor T1. So it starts discharging through thyristor T1 here. Also, voltage across the capacitor, first it reaches to 0 and then it maintains the voltage Vs. So voltage across the thyristor is also same, but the current through the IT2, that is current flowing through the thyristor IT2 is 0. Why? Because no current flow, it is not conducting. Also the charging current, again when the this capacitor charges, it became 0, and same cycle repeat once again. So this is the explanation of this class C commutation, which is also called as complementary commutation. Thank you very much.